Hi guys, welcome to the continuation of Master Crammer Calculus Made Easy series. And in this video we'll be having again more examples with limits on trigonometric functions. So for our first example, we have a limit of sine squared u multiplied by cosine squared u over u squared as u approaches 0. So if you recall, a limit of a function raised to nth number is equal to the nth number of a limit of that function. Just to make it clear, let's put it this way. This is now the limit of sine of u multiplied by cosine of u over u. These are all squared, right? As u approaches 0. Now, you can also express this as the limit of sine u multiplied by cosine u over u as u approaches 0 squared. So the limit of a function raised to the second power as u approaches 0 is also equal to the limit of this function as u approaches 0, and then you take the square of this whole limit. Recall our video on limit laws. If you kind of forgot about it, I would suggest that you go back to our video which discusses the limit laws. So continuing here, so we have here limit of sine u cosine u over u as u approaches 0 and then squared. We can express now this one as a product of two limits. Limit of sine u over u multiplied by limit of cosine u as u approaches 0. So let me rewrite this. The limit of sine u over u as u approaches 0 multiplied by the limit of cosine u as u approaches 0. And then we take the square of this whole expression. So what we did, we got the limit of this sine u over u multiplied by the limit of cosine u as u approaches 0. If you recall, this is the limit of a product of two functions. In this case, the first function is sine u over u, and the other function is cosine u, is equal to the limit of the product of the two functions. In this case, the limit of sine u over u multiplied by the limit of cosine u. All of them now squared. So here, if you recall, the limit of sine u over u as u approaches 0, this will be 1 multiplied by limit of cosine u as u approaches 0. Cosine of 0 will be 1. And then the whole thing squared. 1 times 1 is 1 squared. This is equal to 1. So our final answer is 1. By the way, before we continue further, please remember to click on the subscribe button below to complete our Calculus Made Easy series. This will help you a lot in further understanding calculus. Okay, for our next example, we have limit of sine z over sine of z over 2 as z approaches 0. So let me just write this here. Limit of sine of z, okay, let's put it this way, let's split it a bit, over sine of z over 2 as z approaches 0. Basically, it's the same thing. This expression here is the same as this expression because I just split it. No? Limit of sine z over 1 multiplied by 1 over sine z over 2. 1 times sine z is sine z. 1 times sine z over 2 is sine z over 2. So basically the same. We didn't change anything. Now, let's say we try to multiply this by z. Let's say we you put here Z, okay, so that it will be that there's no effect. Let's put Z here. Now Z over Z is equal to 1, so basically just multiplying by 1. There's no change in our original expression. Now if you have Z over 2 here, let's say I multiply this by Z over 2. Now if I multiply the numerator by Z over 2, then I have to do it in the denominator, Z over 2. So in this case, the Z over 2 here divided by Z over 2 is basically equal to 1. So again, you're not changing our expression. So now, let's simplify this. So basically, this will be the limit of sine of Z over Z as Z approaches 0 multiplied by sine of Z over 2, and sorry, that will be in the denominator. That will be multiplied by Z over 2 divided by sine of Z over 2. And then here you have Z divided by Z over 2. This is basically equal to 2. So Z divided by Z over 2. These two Z's, they cancel, and 1 over 1/2 will be equal to 2. Okay, so now let me just make some space. Okay. Now, what we can do here is, remember this 2 here is just a constant. You can always put this behind here. 2 can be transferred here because it's a constant. Limit of a constant multiplied by a function is simply equal to a constant multiplied by the limit of that function. Again, you can always go back to our video on limit laws to understand this further. Or if you forgot about it, you can always go back to that specific video discussing limit laws. But if you recall that that lesson regarding limit laws, then that's not a problem. Now here, let's put 2 behind. Let's put 2 here. And then now we have here two functions, this one and this one. So we can express this now, again, going back to our limit laws. The limit of the product of two functions is equal, as per the limit law, the limit of two functions. This is one function, the other one is, this is the other function. The limit of the product of two functions is equal to the product of the limit of the individual functions. So in this case, in simple words, now I can write this as 2, because 2 I transferred here, 2 multiplied by the limit, okay, of sine of Z over Z as Z approaches 0, multiplied by the limit of Z over 2 over sine of Z over 2 as Z approaches 0. Now let me just make some space here. Now, limit of sine Z over Z as Z approaches 0 is easy. This is basically 1, right? So this whole thing here is actually equal to 1. So now that's, again, to make it simple, let's, and to save space, let me get the limit here already. So this is basically equal to, we'll have here 2 multiplied by the limit of this equal to 1 multiplied by the limit of Z over 2 over sine of Z over 2 as Z approaches 0. I can rewrite this now into 2 times 1 is 2. Let's say, let me just make it clearer. Let z over 2 be equal to, let's say, x. So if z over 2 is equal to x, we can say that as z approaches 0, okay, if z over 2, let me just write here 2, as z over 2 is, if z over 2 is equal to x, as z approaches 0, if this number approaches 0, then what happens to x? Then x also approaches 0. So now we can write now our equation or our expression as, again, this is 2 times 1, we'll have 2. Limit of z over 2 over sine z over 2 as z approaches 0. Z over 2, we will have the limit of x as z over 2 is equal to x over sine of z over 2 is again equal to x. X. Now, instead of z approaches 0, we'll write x approaches 0. X approaches 0. Now, we can rewrite this again into 2 multiplied by the limit of 1 over sine of x over x as x approaches 0. Let me just put some space here. Okay, so it will be easier to understand. So let's make it a bit cleaner. Okay. Now, 2 limit of 1 over sine of x over x. We have here 2. Now, limit of 1 over sine of x, you can get the limit of 1 as x approaches 0. Again, this is basically the limit of a quotient of two functions. In this case, the first function is 1. The second function is sine x over x. The limit of 1 as x approaches 0. And then the limit of sine x over x as x approaches 0. Again, this is just a limit of quotient of two functions. The first function is 1. Second function is sine x over x. So the limit of 1 as x approaches 0 divided by the limit of sine x over x as x approaches 0. So in this case, the limit of 1 as x approaches 0 will simply be equal to 1 divided by the limit of sine x over x as x approaches 0 is equal to 1. So in this case, this is 2 multiplied by 1. And our final answer, therefore, is equal to 2.